Hi everybody, welcome to our online lesson for 6.1. Today's lesson is on linear inequalities, and last class we started these notes. We looked at what is a linear inequality in one variable, which we've seen before, and then we talked about a linear inequality in two variables. So we've really only, in class, we only covered the first page of our notes. So if you did miss that, you can get that page off of the website. The key to the notes is available, and you can just fill those answers in for the first page of our notes. So I'm going to skip ahead a little bit today. Okay, looking at this right here, we talked about this in class, about most of us, everybody hopefully knows how to rearrange a linear inequation, like this one here. So an equation has an equal sign, and we can move things back and forth on either side of the equal sign, and we can do the exact same thing for linear inequality. Okay, and so we did an example of that in class. I'm just going to do another example down here below because I want to really reinforce this rule right here, which is that you can treat a linear inequality just like an equation, and by that I mean you can get it into y equals mx plus b form, even though we know we don't have an equal sign in a linear inequality, but we can get it in that same order. Y, okay, is greater than or less than mx plus b. But when we do that, we have to be a little bit careful. If we're dividing or multiplying through by a negative number, in order to get rid of a negative sign on the y, we have to make sure that we flip the inequality sign as well. Okay, so it looks like this. Let's look at this example right here. I've got y is greater than or equal to x minus 4. It's in y equals mx plus b form because I've got y first, then x, okay, then the number. The problem is that negative sign in front of my y. Okay, slope intercept form looks like this, and I always have to have a positive y, okay, on its own. So I need to get rid of that negative sign. So I can either, here I can multiply through by -1. The other thing I can do is I can divide by -1. I'm going to divide by -1. And if I do that over here, oopsie, sorry. Okay, if I divide by -1, I'm going to do that to everything. Okay, anything I do to one side of an equation, or in this case, an inequality, I have to do to everything. Okay, so I'm going to divide through by -1, and that's going to give me a positive y here. And I just need to be a little bit careful, because if I divide through, here's my rule. If you have to multiply or divide through by -1 or any negative number, okay, any negative number, then we must flip the inequality sign. So I need to turn this inequality sign the other way if I'm going to divide through by -1. So I'm going to write that now as y is less than or equal to, and let's see, I've got x divided by -1. Well, that's going to be -1x. And -4 divided by -1 is going to give me +4. Okay, so there's my answer for that one. I'm going to do one more example for you. You can add this one to your notes. Okay, here's the other example. What if we have something like this? Let's say I'm given the inequality -2y is greater than or equal to 8. Okay, let's say I've got something like that. Again, if I want to have y all by itself, okay, I recognize that this is going, I see that there's a 0 slope here. Okay, this is going to be on a graph. Okay, I don't know exactly, I have to rearrange it to find out where does that line intersect the y-axis, but I know that this is going to be a horizontal line somewhere on this graph, maybe down here somewhere, or maybe up here. Okay, I've got to figure that out. So what I do is I say, well, I need to know what y is going to be greater or less than. So I need to get y by itself. I'm going to divide through by -2. Okay, and over here I'm going to do the same thing. I'm going to divide by -2. Because I am dividing by a negative number here, I'm going to change that inequality sign. So it looks like this. I get positive y. Okay, and I'm going to flip that inequality sign so that it says that positive y is less than or equal to, well, 8 divided by -2 is -4. And if we just think about it, this makes sense. Because if -y, okay, is greater than or equal to let me see here for a second, sorry, if negative y is greater than or equal to 4, okay, then positive y must be less than or equal to negative 4. Okay, so our graph is going to look like that there, okay, where y is equal to negative 4. Okay, so let's look at how we can graph linear inequalities in two variables. Again, a linear inequality in two variables looks a lot like a regular linear equation, something like this. The linear equation y equals 2x plus 3. Below, I see that I have a linear inequality. I know it's an inequality because I have an inequality sign right there. So it tells me that y is greater than or equal to 2x plus 3. Okay, so how do I graph this? We're going to start by thinking about the boundary that this graph is going to make. Okay, so I know that the graph y equals 2x plus 3 will form the boundary of this linear inequality. So a linear inequality, ladies and gentlemen, is simply a boundary line that we're going to graph, and then we're going to shade, okay, a region either above or below that boundary. So let's go ahead and do that. Okay, so I start by looking at this here and I say, okay, well, I know that the boundary of this is going to be y is equal to 2x plus 3. Okay, that's going to form the boundary of that. So let's go ahead and graph that. If I look at this, it is in y equals mx plus b form. So I don't have to do any rearranging to this equation. This looks great. So that tells me that 3 is my b value. That's my y-intercept. Okay, b is equal to 3. So right away I can go ahead on my graph and I can graph 3, the point 0, 3, which is going to be right here. Okay, that's my b value. The next thing I can do is I can look at the number in front of x, which is the value for m, and that's my slope. Okay, my slope is equal to 2, and I know that this is the rise over the run, and because I see the number 2, I know I can also write that as 2 over 1, and that's going to tell me that my slope is I go up 2 and over 1 for every other data point on my line. So if I start at b, I'm going to go up 2 over 1, and I'm going to put a dot right there. Okay, let's do it the next one. Up 2 over 1, up 2 over 1. Okay, and I can connect those dots with a line. Okay. So let's go ahead and do that. If you wanted to, you could put a few more data points in the other direction. You can simply go down 2, back 1. Okay, down 2, back 1. Okay, and we're going to connect those with a line. Okay, my line's not very straight, I apologize. I'm going to put a little arrow on either side of this line. Okay, so I've just formed the boundary for my linear inequality. There's no restrictions given here. Okay, so the range and domain are not stated. So I'm going to assume that the domain and the range are the set of real numbers. Okay, there's no restrictions stated. So I'm going to assume that this data is continuous. Okay, I'm going to assume that x is all real numbers, and I'm going to assume that y is all real numbers. So I'm going to put the little arrow on the top and the bottom of my line, on my boundary line. Okay, I'm going to assume that this solution set is continuous. Continuous. Okay, the line that we just graphed now is called the boundary. Okay, we call this the boundary line. There's two types of boundary lines that we're going to draw. Okay, and the type of inequality sign that we're given in our linear inequality tells us what type of line to draw. So the line that we just drew in the last example was a solid line, and anytime we have the inequality signs that have a line underneath. So this tells me this is the sign less than or equal to. Okay, and oops, sorry folks. Let's fix that. That should be greater than or equal to. Okay, so anytime I have the possibility of y being equal to the value on the right-hand side, I'm going to use a solid line. Okay, so whenever I see either of these two inequality signs in my linear inequality, I'm going to use a solid line. I can connect my data points with a solid line. That's because there's a possibility of y being equal to whatever the right-hand side of that linear inequality, whatever value we put in for x, okay, plus b. If I don't have a possibility of being equal, so if I have either of these two signs here, okay, greater than or less than, then I'm going to use a dashed line. Okay, and a dashed line means that when I draw my boundary, I don't connect it with a solid line, I use a dashed line instead. Okay, so if you have either of the top two signs, we're going to use a solid line. If we have the bottom two, we're going to use a dashed line, and we call these strict inequalities. Okay, so these bottom two, they're called strict inequalities, meaning that there's absolutely no possibility of being equal. They're either greater than or less than, okay, depending on which sign we see, but it's not equal. All right, let's have a look at just an example then. I'm not going to graph these, but if I saw this linear inequality here, number 1, okay, and if I was to go ahead and graph that, I would draw the boundary as I see that I have the possibility of being equal, so I'm going to use a solid line for that. So I would draw the boundary as a solid line. Okay. In the second example there, okay, if I were to graph that, I see that I have, this is a strict inequality. Okay, y is greater than 2x plus 3, and so I would draw the boundary as a dashed line. Sorry, a little bit better line than that, dashed line. Hopefully your dashed line is straighter than mine.